All right, so here's the review. Determine if it's arithmetic. If it is, find the common difference. So the first one is plus 20, and then not plus 20. So this is not arithmetic. Second one looks like you go minus 9, or plus 9, plus 9, plus 9. So the common difference is 9. So D is equal to 9. Find the 24th term in the sequence. So A of 24 is going to equal our first term, negative 12, plus n value, 24, and negative 12 is the first term, so 24 minus 1 times 9. So that's negative 12 plus 23 times 9. Punch that in the calculator. Get 195. So A to the 24th equals 195. And that is your answer. Number 3, given two terms in arithmetic sequence, find the common difference, the 52nd term and the explicit formula. Remember, we don't need the explicit formula part of it. So we got to find the common difference first. So we're going to go A to the 30th, which is negative 119. That's going to equal A to the 12th, which is negative 47, plus my n value, which was 30. So that would be that n value. So plus 30 minus, in this case, it's going to be A12. Okay, so it's going to be 12. I'm going to sneeze here. Excuse me. So minus 12, and that'll give us the difference. So add 47 to 119 and divide by 18. And we get negative 4. So we get D is equal to negative 4. And then it asks us to find, what, A to the 52nd? So A52 equals, doesn't matter, negative 119 plus 52 minus 30 times negative 4. So negative 119 plus, inside parentheses, 52 minus 30 times negative 4, negative 207. So that's your answer. Next one, so we'll go A to the 40th. I always go the bigger one. Doesn't matter, I guess. 119 is equal to 35 plus my n value for the 119 was 40 minus 19 times D. So 119 minus 35 divided by, what's that, 29? And that's not 29. Idiot. 40 minus 19. 21. $119 minus 35 divided by 21. 4. So D equals 4. So then A to the 52nd is equal to 35. Doesn't matter which one I pick. Plus 52 minus 19 times 4. 35 plus 52 minus 19 times 4. 167. Number 5, given the explicit formula, given the first term and the common difference of the right, find the 52nd term. We're not writing that, so don't worry about the explicit formula. So A to the 52nd is equal to 36 plus 52 minus 1 times negative 5. Oops, syntax error because I got too many things in there. Negative 219. And that is the answer. Negative 219. The next one, a to the 52nd equals 37 plus 52 minus 1 times 30. So 37 plus, parentheses, 52 minus 1 times 30. 1,567. Evaluate the related series. You could just add them up, or you could use the formula. It's 1, 2, you're doing the sequence here. So again, when we're talking the sequence, make sure you use the first term. So it's number of terms. There's 1, 2, 3, 4, 5, 6, 7 terms. So it's 7 times the first term, which is negative 13, plus the last term, which is negative 43. All of that divided by 2. So negative 13 plus negative 43. Divide that by 2 times 7. Negative 196. You just add those all up on your calculator if you wanted to. Number 8, 1, 2, 3, 4, 5, 6, 7. So 7. First term, 42, plus last term, 90, divided by 2. 42 plus 90 equals, divided by 2 equals, times 7 equals 462. Find the sum of, we need our first term. So our first term is a of 1, so 10 times 1 plus 6, minus 6. Let's try this again. So it would be 10 times 1 minus 6, which is equal to 4. We need our last term, so the 10th term, 10 times 10 minus 6, which is 94. So then the number of terms is 10. Then 4 plus 94 divided by 2. So 4 plus 94 divided by 2 times 10, 490. First term is equal to 2 times 1, which is 2. 10th term is 2 times 10, which is 20. So we've got 2 plus 20 divided by 2, and then that's times 10, because that's our number of terms. So 2 plus 20 divided by 2 times 10, 110. Determine the number of terms n in the arithmetic series. So we're going to use a series formula. So series formula is S of n, so we know our x of n is 6,090. That's going to equal the number of terms, which is unknown, times a1 plus an divided by 2. So 4 plus 340 divided by 2 is 172. So 6090 is equal to 172n. Divide 6,090 divided by 172. What did I do? 35? So 35. Next one, 545 equals n times 14 plus 95 divided by 2. So 14 plus 95 divided by 2 is 54.5. 545 equals 54.5n. That would be 10. All right. Second page. Determine if the sequence is geometric. If it is geometric, find the common ratio and name the term in the problem. So we've got geometric sequences. So sorry, I'll edit this out. So in 3, 2, 1. So geometric, determine if the sequence is geometric. If so, 13 times 2 times 2. So yeah, it's geometric. So our ratio is equal to 2. Yes, it's geometric. Our ratio is 2. Then our formula, a of n is equal to a of 1 times r to the n minus 1. So a of 11 is going to equal negative 4 times 2 to the 10th. Negative 4 times 2 raised to the 10th. Negative 4,096. Negative 4,096. Times 4. That's not times 4, so not geometric. Number 15, given two terms in a geometric sequence, find the common ratio. So, I mean, we've given this, we'll make this, do it how we should do it. So negative 48 is going to equal our a of 2 in this case. So negative 12 times r to the 3 minus 2. So it would be negative 48 equals negative 12r. So 48 divided by 12, 4 is our ratio. So r is equal to 4. So then we have to find the 10th term. So a to the 10th is going to equal, that doesn't matter, negative 48 times our ratio, which is 4, but our n value here is 10, but the value that we used was 48, so it's going to be 10 minus 3. So negative 48 times 4 raised to the 7th. Negative 78,000. 786,432. So again, we'll go at 32 is equal to our first term, which is 1, times the ratio to the n. It's going to be 6 minus 1. 32 is my 6th term, 1 is my first term. So 32 equals r to the 5th. So we have to take the 5th root of 32. The 5th root of 32 is probably 2. So my ratio is equal to 2. So the 9th term is going to be 1 times 2 to the 9 minus 1. So 2 to the 8th is 256. Number 17, given the first term and the common ratio. So a to the 9th equals negative 3 times negative 4 to the 9 minus 1. So negative 3 times negative 4 raised to the 8th. Negative 196,608. A to the 11th is equal to negative 1 times 2 to the 11 minus 1. So negative 1 times 2 raised to the 10th. negative 1,024. The last one then is we've got the geometric series. Formula for the geometric series, I'll just kind of write it down here. S to the n is equal to your first term times 1 minus r to the n over 1 minus r. So we got to kind of, they don't give us the ratio, like in the first one, they don't give us the ratio, so we got to figure it out. So for 19, this r is equal to negative 2. So then we're going to have a1, which is 1 times 1 minus negative 2 to the n. That's an n. N value is 7. All over 1 minus r, so 1 minus negative 2. Calculate that out, and you get 43. Got to punch all that in your calculator, and hopefully you get 43. 1 minus negative 2 raised to the 7th. Yep, divided by, yep, that one works. So this would be, again, 1. The ratio looks like it's negative 4. So 1 minus negative 4 raised to the 9th, all divided by 1 minus negative 4. Calculate that all out, and you should get 52,429. So number 21, they give us everything. So we've got 1 times 1 minus negative 2, my n value is 8, divided by 1 minus r, so 1 minus negative 2. So we've got 1 minus negative 2 raised to the 8th, divided by 3, negative 85. This one, we've got 1 times 1 minus 3 to the 10th over 1 minus 3. So we've got 1 minus 3 raised to the 10th. Divide that by negative 2. 29,524. Let's try this again. 29,524. 23 and 24, you have to use logarithms to do those, so we will not put those on the test.